Darwin respond? Did Darwin respond? Yes, he responded. Darwin writes in 1860, I have been much interested by Mr. Patrick Matthews' communication in the number of your paper dated April 7th. That's my birthday, actually. I freely acknowledge that Mr. Matthew had anticipated by many years the explanation which I've offered on the origin of species under the name of natural selection. I think that no one will feel surprised that neither I nor apparently any other naturalist had heard of Mr. Matthews' views, considering how briefly they are given and that they appeared in the appendix to a work on naval timber and arboriculture. I can do no more than offer my apologies to Mr. Matthew for my entire ignorance of his publication. If another edition of my work is called for, I will insert a notice to the foregoing effect. And did he? Yes, he did. He did in the third edition of The Origin of Species. He made a reference to this discovery. And so the interesting thing is actually Mr. Matthew was kind of satisfied, and he had a business card, that said Mr. Patrick Matthew, discoverer of evolution by natural selection. So is this the end of the story? Anything else that we have to add here, Is there anybody else? Well, James Hutton in 1794 uses natural selection for the improvement of varieties in species. William Charles Wells in 1813 proposes that natural selection can lead to new varieties in species. Edward Blyth in 1835 uses natural selection as a process to preserve the unchanging essence of a stable species. Darwin was the last one to discover evolution. You have to understand this is a great achievement, because after him, nobody discovered evolution again. This is really the person who kind of nails it, but it was the talk of the time. It was something that was very naturally being produced out there. I think this is a very important lesson. A physicist that he visited in South Africa said to him, the most important scientific question of our time is how evolution gives rise to new species. By the way, so what was actually then really new in Darwin's work was only that he says natural selection gives rise to new species. None of them said this, new species. But the curious thing is nobody believed that. So of Darwin's great followers, they believed everything that he wrote, but they did not believe that natural selection can give rise to new species. And this was only sorted out by the important work of Ernst Mayr much later, according to Ernst Mayer's opinion. So that is very interesting. So when Darwin died in 1882, there were three objections to his theory that he considered problems. And one was really the age of the sun. So the most important physicist of the time, Lord Kelvin, had calculated the age of the sun as a chemical reaction and had concluded 200,000 years. And Darwin did not know what to do with that figure. He thought maybe that's not long enough for evolution, but I am not the person to challenge a physicist. That was now, of course, we know the calculation wasn't right because Kelvin did not know of nuclear fusion. The second problem was an even bigger problem. An engineer pointed out to Darwin, what you describe is blending inheritance. So Darwin only knew about blending inheritance. So he said, let's suppose height, let's suppose the father is 180, the mother is 170. On average, the child will be 175. That's blending inheritance. The engineer said, let's think that through. If we have a beginning, the population, everybody has some different height, they reproduce, the difference gets reduced. After some time, everybody is 175, and where is your evolution? It doesn't continue. Darwin did not know how to answer that question. The answer will come with Mendel. But the last thing that also kind of small, Darwin said, if you can show a trait that exists in a species for the benefit of another species, that would be a challenge to my theory. So that leads us actually into cooperation. So in some sense, evolution of cooperation is something that Darwin left open. So blending inheritance was then really solved by the work of the Austrian abbot Gregor Mendel. And he published in 1865, and in 1865 in the Brünn Academy of Sciences, But nobody, so Darwin, who read widely, he did not read Mendel, but he's also excused because the president of the Brunner Academy of Sciences summarized the achievements of this year as nothing relevant discovered this year. This was the beginning of genetics. So Mendel figured out that inheritance is not blending but particulate. You can think of digital items. And when that was realized by the evolutionary biologists who all believed in blending inheritance, they thought, oh, well, we have a problem. Is Darwinian evolution even compatible with particulate inheritance? And that really led to this birthplace of population genetics, which is sometimes called the neo-Darwinian synthesis. So this was then the beginning of a mathematical description of evolution, which I think is very, very important. And this was the work of Ronald Fisher, G.B.S. Holden, and Sewell Wright, approximately in the 20s and 30s. So they showed how natural selection works together with Mendelian genetics. In order to make progress, I now want to ask the question, what is it that evolves? Because we often talk about evolution, and Ernst Mayr in his book actually asks that question and discusses it beautifully. What is it that evolves? We talk about evolution of the brain, we talk about evolution of species, evolution of genes, but what is actually the carrier of the evolutionary process? And Ernst Mayr points out correctly, the only thing that evolves is a population of reproducing individuals. So these other things evolve figuratively, but when we really think about evolution, we have to invoke a population of reproducing individuals. And this is what I describe as my equation. So it's always about populations. And then the first principle of evolution is mutation. Mutation means that there's new variation coming about, and selection means that there is different growth rates for different types over time. And you write those things down mathematically and you can study this. So these are the two fundamental principles of evolution, mutation and selection. Mutation generates variation and selection acts on variation. And to those, I have proposed over the last 20 or more years that we should actually add a third principle, and this third principle is cooperation. And cooperation means that units, cells, individuals help each other so much that they become a new level of organization. So in my analysis, in my interpretation, cooperation is the master architect of the evolutionary process. It is not only competition, it is